So as I was saying before, we are timed out. Central limit theorem, what is saying that the sample size increases, then the distribution of the sample means will approximately normally, or we approach normal distribution. So it will have the shape of a normal distribution curve. That's basically what it is saying. But the sample size, as long as the sample size is selected randomly from the population with replacement. Now, in that case, when it happens, the mean of the sample will also be equal to the mean of the population. And the standard deviation of the sample will be equal to the standard deviation divided by the square root of n. So two things are added here: sample mean and sample size. So which modified the formula that we are using for transformation to this. This is actually x bar. Z equals to s bar minus mean of standard deviation divided by the square root of n. So instead of using the other formula we were using before, if you can recall, you know that the formula we were using before was this one. See? But now sample size and sample mean were added, which give us a modified formula for transformation. So we use it when you have the sample size is given and the sample mean is also given. So S by the sample mean, and of course N represent the sample size. Everything remains the same. Let's see how this works. Let's try one example. You can then practice any other example you like. It says here that the Nelson reported that children between 2 to 5 watched on average 25 hours of TV per week. Assume that the variable is normally distributed and the standard deviation is 3 hours. Now, if 20 children were selected of that age, find the probability that the mean number of the hours they watch TV will be greater than 26.3 hours. So the same thing we are doing before when we are doing normal distribution as the application of normal distribution. But this time around, we have to factor in the sample size and the sample mean. So let's put them all together and solve this example. Okay, say Nielsen reported that the average age, that the children between age of 2 and 5 years watch on average 25 hours of TV per week. So that which means that our mean, I'm gonna move this now. Mean is 25 hours of TV. And they say, assume that the variable is normally distributed and the standard deviation is 3. So our standard deviation is 3. Okay. Now it says 3. Now if enter, okay. Now it says if 20 children were selected, that means n is 20. N is 20. Right? So if 20 were selected between, let's say, find the probability that the mean of that 20, that is sample mean. The sample mean we'll get from the this workbook will not give us that character. So we get it from the workbook. It says sample mean is 23.6 hours. So you say if find the probability that they watch TV, sorry, the mean number of hours they watch TV will be greater than 26.3 hours. So let me write it down. 26.3 hours. 26.3 hours. So let me put it in. We go to our other workbook to get the sample mean. Got 26.3. What is the other table? Okay, other workbook. I didn't see it. So I'm going to open it. Let me open the another Word document because I didn't see the other workbook. It looks like you have only one workbook. Okay. Then I will share it. Okay, the show all windows here. Okay, so now insert equation. So you have the, see this is what will give us that character. I'm gonna move this away from here. See, it's x bar. That's this one right there. X bar, okay, equals 26.3. Yeah. So I'm gonna copy this. Yeah, I'm gonna move this. So I'm gonna put it in. All right. Where are we here? Put the color right there. See S bar, that's how it looks like. S bar. Okay, all right. So we have all the numbers. So now say sample size of 20. They mean that the watch TV is 25 hours with a standard deviation of 3 hours. So if 20 children were selected of that age, find the probability that the mean number of hours they watch TV will be greater than 26.3 hours. So we plug this into our formula to transform it. So we have Z equals X bar minus mean divided by standard deviation over root n, which gives us equals S bar is 26.3 minus mean of 25, okay, divided by standard deviation of 3 over square root of n. You know what? Let me put it on that workbook. That other workbook will be better, make it look better. So I'm gonna make it so you won't get confused. Z equals. Give me 1 minute. Let me write them down. I'll put it in that workbook. Plus 25. What was standard deviation of 3 plus square root of 20. Let's put it that place. That'll be better for us. Make it more understandable. So I'm gonna go to that other workbook. Put the formula in. That's right here. So we have it as equals, okay. Put this in. We gotta have this equation. Okay, have x minus mean 26.3 minus mean of 25, but by standard deviation of, and then the root n, 3 by square root of n. Square root of n is 20, so you're gonna be square root of 20. 20. Okay. Equals. Now let's plug this in the calculator, and then we get our answer, and then we can now find the probability. To have this 26.3, 26.3 minus 25 divided by, okay, standard deviation of 3 by root n, 3 divided by square root of 20. Okay, close this. Give us 1.94 rounded, 1.94. 1.94. Okay, so go back to where we are and 1.94. 1.94, which we copy and paste it in the main workbook so that we can answer the probability question they asked there. Okay, so you can see that this is better than what we had before. See? Much better and more understandable. So now it is no longer 26.3. It is now 1.94. It's no longer S bar. It's now Z. So that the probability that the mean number of hours they watch TV is greater than 26.5 hours becomes the probability of Z greater than 1.94. Greater than 1.94. 1.94. So let me make it big. Okay. Make it big. Equals. Now, to answer that, we need our chart. So make a small chart here. Okay. Let's say we have it from here. I can draw it on the side. The same chart we'll be drawing all day. So we have our 0 at the middle, 1.94. Okay. We can put our x-axis on the center line that shows the mean. Then the line that shows 1.94. So it says that they'll be greater than 26.3, which means greater than 1.94. So that means it's gonna be on the tail, right there. So we shed it. So it's still the same process. So that this time sample size is involved and sample mean is also involved. That's all. So that means there's slight modification of the transformation formula. That's it. Okay. So the required probability now becomes, see, half of this is 0.5. So we're looking for only this portion. So we're gonna do 0.5. Okay, minus whatever answer we pay from the table for 1.94. So we'll go to the table, look for 1.94 on the table. 1.9 is right here. That's right here, under 4. 0, 1, 2, 3, 4. You can see right there, 4 right there. And 1.9. I got 0.4738. Let me write it down. 0.4738. So we go back and put 0.4738. 0.4738. And that will give us the required answer. The answer we are looking for. That will be equals from the calculator we can get the difference. 0.55000. Okay, minus 0.4738. 0.0262. 0.0262. 0.0262. 62. So this is it. That's central unit for you. So
hello, Professor.
Yes, ma'am.
The 0.4738, where is it from?
For the table of normal distribution, look for 1.94.
1.94, okay.
You go to table 1.94. I can see right 1.9. Go under 4.
Okay, 0.4738. Yeah, I saw it.
So we subtracting this time, Professor?
Yeah, and I'll explain why. Because see, remember the whole of this section is 0.5, right? But you are looking for only the shaded part. So you gotta make 0.5 minus the number you see on the table to get only this part. Yes. Any other question? Excellent. So now,
Can I see the question to this solution?
Huh?
Can I see the question to this solution?
Yeah, sure. It's right here. So now, practice as much as you can in your textbooks. Even I solved some example in the textbook, so you can also look up there. Abadi, you there? Abadi,
Yes. Yes.
so they can leave us now. Leave us
All right.
alone
Thank
now.
you, sir. Yes, sir.
Abimbola?
I'm present. Abimbola is present.
Tomorrow. Brandy.
Yes, I'm here.
So I see you tomorrow, Brandy. Okay.
What about Abimbola? Can I leave?
Yeah. Once I call you, if you answer, you can leave. Adenike.
Oh.
Adenike, you here? Let's see, we lost him.
Present, I'm here.
Bakari, you there?
Yes, Professor, I'm here.
And Adenike, sir.
Adenike, you there?
Okay, Adenike.
Okay. So we'll see you tomorrow then.
All right, sir. Good night.
Professor, did you get back already?
Yeah, I got it. Bami Shola.
I'm here.
Tomorrow, Brandy, I've called you already. So Ramos, Ramos.
Yes, I'm here.
Ramos, I see you tomorrow, okay?
Okay, bye.
Miss Brown, you there?
Yes, I'm here.
Brown, see you tomorrow then.
See you.
Leonel Fonsi.
Yes, Prof, I'm here.
All right, tomorrow, eh? Have a nice
Tomorrow.
night. Yeah.
You too. Bye-bye.
Loveless.
Yes, I'm here. Have a good night, Professor.
Miss Lizzie, you there? Lizzie. I think she's gone. Nicholas, Rossell.
I'm here. Good night.
Harris.
Yes, I'm here.
All right. Good night.
Have a good
Did you hear
night.
me, Professor?
What's your name?
Lovelace.
Yeah, I called you. Lovelace. I did.
Okay. Good night.
Good night.
Professor.
Professor, you have not called me Bello.
Yeah, I'm still calling. Yeah, no problem. Somebody wants to ask me a question. Yeah.
Yeah, Professor, are you gonna put this up on
Yeah, right?
yeah, download it for us?
Yeah, I'm gonna put it like I used to put.
With the work that we did so we can go over it.
Yeah, you mean the yeah, sure. Let me save it again. I saved the other one.
All right, great. Thank you.
So you're welcome. Castillo account.
Yes, I'm here.
Okay, good night. Fumilayo.
Yeah, Bello. Good night.
Graves. Shamana Graves.
I'm here, Professor.
All right, tomorrow, okay?
I see you tomorrow.
Tyree.
I'm here.
Tomorrow. Tevonda.
I'm here.
You got Tyree?
Yeah, I got Tyree, yes.
All right, have a good night.
You too. Good night.
This is Savonda. I'm here too.
Sonali is here. I think we lost Sonali.
Did you hear me?
Tevonda, right?
Yes.
I checked your name on that. I heard you when I called you the first time. Yeah.
Okay, good night.
Good night. Yeah, sure. All right. So I see you guys all tomorrow and enjoy your night.